All right, good afternoon, everybody. So we are back again for another discussion on testing. Hopefully we'll grade your quizzes relatively soon. But one thing I wanted to talk about today and related to testing, there's a couple of things. One is some of the basics of how to generate good tests, of how to test our code in a way that makes sense. Because one of the things that we talked about, I mentioned yesterday, is kind of the wrong idea we might have about testing, that we think that oftentimes we think that testing is supposed to prove that something works. The truth is we cannot do that. We cannot prove that a system works, not easily. And what we're really trying to do is we're trying to find places where it doesn't work. Because ideally, we want to find those errors. We want to find the problems so that we can fix them. We don't want our users and our customers to find the problems for us, because that's usually going to result in a much more expensive, costly in terms of time, in terms of money, in terms of reliability, that people will have trust in our ability to produce good software. All of those things will be a cost to us when our users find problems in our code that we were not able to find. So, but one of the things that I was pointing out, that I was saying a second ago, let me find it here. So the size of an integer in Java, do you guys remember how many bits is an integer, or how many bits, bytes, however you want to look at it? Does anyone remember? Yes, 32 bits, right? So that means that every integer has a potential of 2 to the 32 possible values, right? So let's imagine that we wanted to test to make sure that it absolutely works, a simple method that all it does is it takes one integer and a second integer and it adds them together and returns the sum, okay? Pretty easy, right? Now I can type it up right here. Right, you guys could probably type this in pretty quick too, where it's just something like that would basically be a sum function or a sum method, right? Now, if A has 2 to the 32 possible values and B has 2 to the 32 possible values, for us to test every possible input to verify that the correct output is obtained, we would have to test 2 to the 32 times 2 to the 32, so 2 to the 64 test cases, which is a lot, in case you didn't know. Okay, so 2 to the 10th is around 1,000. Yeah, 2 to the 10th is 1,020, 1,000. 1024, right? 2 to the 20th is around 1,000,000. 2 to the 30th is around 1,000,000,000. You getting the idea? Trillion. Like, what comes after trillion? Million, trillion, million, billion, trillion. Is there a gazillion? I don't even know what the numbers are. That's how big it is. That's how many test cases we would have to run, right? So we can't do that, but we can test some values, some subset of those values, but we need to be smart about how we do that. Okay, so there's a couple of concepts I want you to understand. One is the concept of code coverage, because the question will come out, how many test cases should I run? Like, how many test cases would you think you need to run on a simple method like this, a sum method that all it does is add two numbers together and return the result? How many test cases? One? Well, probably not, because if your test case is some 1 and 1 and make sure that it returns 2, right? That should be the not less than, but greater than symbol. Anyway, make sure that sum 1 and 1 returns 2. Then if somebody coded that method up like this, it's just pseudocode, by the way. If somebody coded up your method like this, they would pass your test case, right? And you would wrongly think that this method is correct if you only had one test case. So we need at least one. We need at least. Let me do something here. I want to delete this because this is not connected to what I'm talking about. So if you just test one test case, right, like that, you might get a test pass wrongly, right? You might get a test pass even though the method is not correct. So we need to have enough test cases that we can have confidence that we have thoroughly tested it. Okay, so one concept, now let me add this back in now, this code coverage. Okay, one concept is what we call code coverage. So the idea of code coverage would be if you had like an if statement. I can pull this up over here actually. Let me see if there's an if statement in this code somewhere. Oh, that's a test. Okay, we don't have that. Okay, so something like, I don't have an example in here. Let me, I don't have an example of an if statement. But let's say you had an if statement. So let me throw one in here real quick. I'll bring it up over here for you guys to see. So for whatever reason, we have this method that what it's supposed to do is if A is greater than 0, if A is positive and B is positive, then we're going to return A plus B, otherwise return 0. Okay, so we have a method. I'm just making something up here just to have an if statement. Okay, so at least what code coverage would say is we need to have at least every line of code executed as part of our test suite, not our test case. A single test case should not execute every line of code in our system, but we need to have every line of code executed at least once sometime during our test suite, all of our test cases put together. So we would have a test case that would run this if statement. It would return a value. Both A and B would be positive. Okay. Then we would have a test case to execute this. So we would need at least two test cases to test this method. Okay. I would argue also you would want actually at least four test cases. And here's the way I would look it out. Here's my 4 test cases. Okay. 1, both A and B positive. 2, A positive, B negative. You see where I'm going with this? A negative, B positive. and 4, A negative, B negative. So this way, we test every possible combination of that and, right? The result of that and. Because we want to know what happens if both this is true and this is true. Do we get the result we're expecting? Okay. Also, we want to know, if one of these is false but not the other, does this accurately give us the result we're expecting? Okay. Now notice it's not just about we're just testing for a particular result. All of these last ones should result in 0, right? And this one should result in whatever A plus B is. All right. Okay. And I would say this is an at least 4 of these test cases would be necessary to thoroughly test this method. Okay. All right. So what I'm going to do now is hopefully if this will work. Let's see. Come on. I'm going to try to join through my other device here. If this will work. All right. Let me share the screen. Okay, so that should be working now. All right, so now what I'm going to do is hold this up so you guys can see it. All right. So here's kind of also how we need to think about testing too, because here we have somewhat of a border test, but let's also think about how we test what's called boundary conditions. So let's imagine that we're developing a store program. Oh wait, that sounds familiar. Yeah, you are developing a store program. Okay, so we're developing a store program, and one of our requirements that our customer wants to add is they want to add this discount feature. Okay, so we'll call that an indidim, right? Okay. Now, what they want to do is they want to say that if a customer spends up to, say, 100 tele, okay, so 0 to 100 tele, they get no discount. They just pay what they bought, right? So no discount. Okay. If they spend between 100, come on. Let me actually, where are we at? Oh, there's my undo right there. That's what I'm trying to do. There we go. Okay. If they spend 100 to 200 tele, then we're going to give them a 5% discount. And if they spend 200 or more, then we give them a 10% discount. All right. So this is how we're going to try to develop our system. Okay. Now, you might think, okay, well, I'm going to have one test case that covers. I'm going to have one test case that covers this, and I'm going to have one test case that covers this, and I'm going to have one test case that covers this, and that'll be enough, right, Hojam? It would be good. That wouldn't be enough, though, the way that good, proper testing is done. Okay. The way that we would do this is we would say, okay, we're going to look at this as a spectrum. Okay, so you have and there's a 200 here, There's a 100 here. There's a 0 over here. And there's a reason why I left a little bit of space on the left there for the other 0. Okay. Because what we're saying is our if statements are going to include three boundaries. Right? One of the boundaries will be here. One of the boundaries will be here. And one of the boundaries will be here. Okay. And what we want to do is we want to test around the boundaries. All right. So we would like to test something that is exactly this value, something that is just to the left of it, and something that is just to the right of it to make sure that those outputs are correct. Okay. And we want to do the same thing here. And we actually want to do the same thing here because there is actually an invalid value down there, right? What is a negative amount? Yeah, I've never gone to Migros, A101, never, not one of those places. And did they finish, scanning all of my items and tell me, oh, after all these items, we owe you money? Never has that happened to me. If it's ever happened to you, you need to let me know what store that is because I'd like to start shopping there. Okay, so boundary conditions mean we're going to test at least 9 test cases here. Okay, so we're going to test something like negative 0.1. We're going to test the exact value 0. We're going to test 0.1, something just to the right of it. We're then going to test 99.9 and 100 and 100.1 or something like that. And then the same thing over here, 199.9, 200, and then 200.1. Notice that by testing this one here, by testing this one here, and that don't work so well. Testing this value here and testing this value here. We are testing in that range, right? We are testing this region by testing those 2 values. So we did include inside the region. We just want to test specifically right around the boundaries because that's where the most likely amount of irregular behavior is likely to occur, right? And so we want to test right around the boundary as much as possible. So I'm going to call that boundary conditions. So we test boundary conditions. Okay. And then finally, one thing we also want to test is we want to test error conditions. Okay, so this might be an example of an error condition we want to test. Okay. Is a negative value, is it supposed to throw an exception? And if it is, then we need to make sure that it does. Okay. All right, so let's see here. Let me switch back to here so I can share this screen. If it lets me. It always makes me do it twice. I don't know what the deal is with Teams. All right, so let's go back to the example that I had before where I said, okay, this let's see. So I have this course and student setup that I put in from before. All right. Now, what I've got is I've got a course that has information like its code, its title, how many akatase is it, what's its prerequisite, prerequisite being a course that you're supposed to take before you take another course. So like, for example, 101, it should be a prerequisite for 102. You should pass 101 before you take 102, but not always does that work out. So let's see. So we have this, so we talked about last time some of these test cases we could do here, right? One other thing I want to introduce you guys to here is how to test for an error condition. Because remember, one of the things that we talked about is if an exception occurs inside of a method, inside of a test method, that is viewed by the test runner as a failed test case. So let me show you an example. This way. Let me try that again. Okay, so it all runs, and then when I run it, I'll get a failed test case because I divided by 0. That's not an assertion. I didn't use the assert equals. I didn't have to. If an uncaught exception occurs here, then we're going to get an error, a failed test case. So if I say, okay, well, I'll just make it 1 then. All right. Then we run it. Now it passes. It passes because there's no exception that occurs. Okay. So the reason why I want to bring this up is because how do you test for an error condition? Well, let's take a look at our code for this set AKTC method. Okay. If it's less than 0, we want to have a new exception. If it's this invalid AKTC exception, otherwise we set it appropriately. So we could have so we already tested the set AKTC method with a normal value, with a valid value. Okay, let's check set AKTC, but instead of giving it 6, let's give it our boundary conditions, right? So what were our boundaries? Here. What's our boundary conditions for the AKTC value? Where is our boundary at for this method? Where's our boundary? What value? No. Well, but it's an int, so we wouldn't be able to do 0.1, but our boundary is right at 0, right? So you're on the right idea. So we want to test -1. Okay. So we want to test -1, we want to test 0, and we want to test 1. Okay, we want to make sure that those produce expected behavior. All right. So we test it at 1. We make sure. Oh, that's a wrong message, isn't it? Ooh, y'all didn't catch that yesterday. And this is title. Y'all, we did not catch that yesterday at all, did we? Okay. So we're gonna.
It's 14 hours.
8, 9, and this is gonna set it at 0. And this is Gonna set it as -1. And let's say we initially write our test cases to check, okay, do those values come through correctly? Okay. And when we run it, we should get 2 failures, right? Oh. We allow it to be 0? Oh, we only, Okay, I guess, does that seem reasonable? Are there courses here at the university that have 0 akatese? Are there any courses with 0 akatese? Yeah, I didn't think so. So, yeah, so I think we have, this is a great example. Let me tell you what this is. This is a great example of a past test case that's probably not right. Are there hobby classes? Gosh, I just don't know. Let's say, oh, do they? Okay. All right. Well, then we'll allow it. We'll allow it. All right. But let's say that this was supposed to be positive and only positive, then this would be an example of code that is not correct, but the test case passes. So basically, here's kind of the breakdown of the possible outcomes. A passed test case could represent code that is correct and a test case that correctly tests it. A passed test case could mean code that's incorrect, but the test case did not catch the error. A failed test case could mean code that's improperly written and the test case is correct and it caught an error in the code. A failed test case could be code that is correct, but the test case is wrong. And that's what actually this one here is. This TC009 is an example of a test case that is incorrect, but the code is correct. Okay. So, all right, so here's a problem. We want this to result in an error, right? So if we were to say, just run this, we want this code to create, if an exception occurs in this line, that's our expected result, right? We want an exception to happen. So how can we test to make sure that an exception occurred? Let me see if I can explain it in a little slightly different wording here. Under normal execution, like this one here, an exception means the code is not correct. Completion, the method completing without an exception means the code is correct. If an exception occurs, there's something wrong in the code. If no exception occurs, then the code is correct. Here, the exact opposite is true. If an exception, a specific exception, but if an exception occurs, the code could be correct. But if no exception occurs, the code is wrong. So how can we find out if an exception occurred in this line of code? How can you find out if an exception occurred? Yeah, good, good. That's something you guys just got a couple weeks ago. So, right, you can use a try block. So we're going to try this line of code. And we'll catch the exception. Right? But we don't want to catch any exception, right? What kind of exception are we supposed to? We want to test specifically for an invalid AKTC exception. Right? And if we catch this invalid AKTC exception, guess what? We do nothing. Right? Because by doing nothing, we guarantee completion of the method because this is the correct expected behavior, right? Okay. So then when we run it, we get our passed test case and everybody's happy. Because here, if you do this catch exception, right, and run it, you get a passed test case, but you could get a passed test case if they throw any exception. That's right. It doesn't like me doing things like oh, you too, huh? Okay. All right. So now when we go to run this test, notice it passed the test case, but this did not throw the correct exception. By catching the correct exception type, let me come down here. By catching the correct exception type, when we go to run it, where are you? What are you talking about? Oh, that's my other conditions up here. Doesn't like this, just throwing or old. Does it do that if I do runtime exception? Let's find out. Is that going to cause a problem too? Okay, let's go that way. I think that works. Okay, that's what I need to do. Okay. Ah, that's better. Okay. So by catching the correct exception type, it can check to see that the correct exception was actually thrown. So if we run it, notice that now I get a failure on this, and the reason why is because the exception, that the just general runtime exception, was not caught, right? So this is not the correct exception that was thrown. It threw an exception, right? This one, but it was not the correct exception. Okay. By testing specifically that a particular exception occurs, I guarantee that only a correct exception being thrown executes. Okay. Do I have one more thing we need to do? Because oh yeah, sorry. Okay, so that's right. Because there is one more small problem with my test cases, the way that they're done. Okay, good. I got my past test case. Okay, and that is, what if there is no exception thrown? I just said this I get to say equals I get to say. This is now incorrect code, right? This does not do what it's supposed to do. If I get to say is negative, it just assigns it, and that's fine. So if I go to compile this and run it, I get a pass test case. So that's not right, right? This is an example of where bad code passes a bad test case, an incomplete test case. So we need to do one other thing, right? Somehow we need that if it doesn't come into here, an exception occurs. Somehow, if we don't get an exception in this line, this test case fails. How can we do that? What do you think? Wait, no ideas? Yeah, we can throw an exception, right? Because if this line creates an exception, then it'll come down to here, right? If it creates the correct exception, invalid AKTC, it'll come into here and it'll exit. No problem. That's the pass. We're good. If it generates an incorrect exception type, runtime exception, for example, or some other exception type, then it will end here. It will try to catch it, but wrong exception type, so it will just jump out here. It has an exception out there. It'll generate an error. Incorrect. So failed test case, exactly what we expect. So what we need is that if this line executes and no exception occurs, then that means we could go to the next line. And then we could throw an exception here. But what we really want to do is we want to use these assert statements. We want to use these assert statements to say this is how an exception occurs. Okay, we want to use the assert statements to give ourselves messages. Why did this exception occur? Why did this test fail? Okay, so we can use that that example from the test that always fails that we saw when we first created this test suite, right? Of course, I could just say allowed negative value. So we're giving ourselves a message of why did this fail, and we want to force this to be false, right? So if we say assert equals 0 equals 1, of course I could say allowed a negative value. So now when we go to run this, right, we get a failed test case, and the reason why was that the course octase allowed a negative value. Okay, so we were allowed a negative value that was not okay. So now if we go back and we say, oh, that's a problem. Yeah, we're supposed to not allow negative values. So we will throw our exception like we're supposed to. We'll build our code, and then we will run our test cases. And now we pass, right? Because now we've tested, did an exception occur? Yes. Was it the correct exception? Yes, do nothing. And the method, everybody's happy. Did an exception occur? Yes. The wrong exception occurred. Okay, there's no second catch block, so we do that. Okay. Now what you could do is notice that when we did this before, runtime, right? Oh, that's right. You need to take that out. Okay. When we threw the wrong exception type, when we run our test cases here, we get a test failure like we expect, but not really any message that tells us why. What we can do to help with that is we can have another catch block that just catches any exception. And make the result of this the same thing, right? So now, course I could say negative value, wrong exception. Right. So now when we run it, we get an error message that is more understandable for us. The wrong exception occurred. We can do that to give ourselves a little bit more information about why this test failed. So now let's go back and return this the way it should. Okay. So now we've tested, did an exception occur? If so, yes. Was it the right one? Yes, do nothing. What, did an exception occur? Yes. Wrong exception? Okay. Error. That's a failed test case. Did an exception occur? No. Okay. Error. That's a failed test case. All right. So this is the way that you can test for exceptions, because when you want an exception to occur, you need to wait to be able to test that an exception occurred. All right. So hopefully also you can see how sometimes when you guys have submitted code in the past, like last year in 101 and in other courses, and you said, well, I don't understand why I got a lower grade than I was expecting. It worked on my computer. Sometimes we test more thoroughly than you might test, sometimes. And so understand that we test different values, and we try to test a little bit more thoroughly to make sure that your code is accurately representing what it's supposed to do. Okay, so we're out of time. If there are any questions or comments about testing, again, this is one of my areas of interest, and it was my first experience working in software development was as a tester, and so I love talking about testing and how to do it. So if you guys want to talk more about that, we can do that outside of the class. But other than that, we will move on to abstract classes starting next week. Okay, I believe it's abstract classes. Maybe I should check and make sure before I say that. I think it's abstract classes. I think that's right. All right. So have a good afternoon. Have a good lab tomorrow for those of you who are still taking the lab section, and I will see you in a week, Wednesday. All right. Have a good weekend.